from all over the place at the same fluxes?
Hello, we are students from Huria High School. We are representing Algeria from Constantine. So we have participated in the reconstruction of events from the Pierre Auger observatory, and we will try to analyze the results. So as we can see that the points are located in the south under the equator line, and this is due to or because of the Pierre Auger observatory, which is located in the south. So we can't see the other part of the sky. I mean the north. That's why there is no detected events in the north. And also we can say that they are isotropic, the points. So we don't have a specific place, or we don't know the origin of cosmic rays, but we can say that they are not coming from the sun, because we can see that the direction isn't from the sun. And we can also say that they are not coming from our galaxy, because if they are coming from our galaxy, we will see that the detected or the points will be situated on the pan of the galactic pan. So we don't have a specific answer about the origin of these cosmic rays, but we can say that maybe they are coming from supernovas, or they are coming from supermassive, like the black holes. These are just predictions, so we don't know exactly the origin of cosmic rays. And I think this is the purpose of this masterclass, is to try to help the Pierre Auger to find the specific origin of cosmic rays. Thank you.
Thank you so much. It was a perfect question, perfect answer. It touched on so many things. I'm going to try to keep up with you. And so yeah, you're absolutely correct. One of the first things we can say is that these particles, the particles with the highest energies we know of, they do not appear to be coming from the sun, because we know exactly where the sun is and we see them coming from other directions. We also see very clearly, as we already has been said, that they're not coming from, they don't appear to be coming from the galaxy, as they don't, when we see these maps, either by the galactic coordinates or with the equatorial coordinates, they do not appear to be coming from the galactic plane, which is what we would expect if they were coming from the galaxy. But we can also, so if they're not coming from our solar system, they're not coming from the sun, they're not coming from the galaxy, we are by exclusion coming to our conclusions from what they may be coming from. So that leaves us with that their source must be extragalactic. And when we take a look at these maps, I agree with you. It's very hard to say one specific region of the sky where they appear to be coming the most. They come from everywhere, but you can see here in this the color diagram, you can see the flux changes, and we have regions which are hotter and regions that are colder. And you can maybe say there's this large region that appears to be hotter and a region that appears to be colder. So maybe those are our hotspots. But if we take a look at the last maps, there's something we need to be very careful when doing any kind of study where we're looking at a large number of events, is the significance, the statistical significance of the data we are collecting. So we need to know how sure we are of the results we are getting. And we can only be so sure as the number of events we are watching, right? So even with all of your results combined, we are not still looking at that much data that allows us to have a very clear picture of where these events are coming from. So for that, we need to...
Yeah, we need to collect more data. And in fact, the public data of the PRLG Observatory, which is the one you have analyzed today, is only 10% of the total data that has been acquired. I will show you now what would be the result of this analysis, what is the result of this analysis performed with the full data from the PRLG Observatory. This has been published in a scientific journal. And you can see here the final sky map that the PRLG Observatory obtained, analyzing the full data set. And this is in equatorial coordinates. This has a very high statistical significance. You see the number of events here is so high that the fluctuations in color that we see are not dominated by the lack of statistics, by the lack of events. So we have enough events to be sure that this pattern is a real pattern that is giving us information of where the sources are. You've already told us that the sources are spread throughout, are not coming from the sun or from the Milky Way, so they are spread throughout all the universe, coming from other, from where, we don't know. But what this clear pattern allows us to conclude the following. You can see that this is a clear pattern, or this part of the sky, this is a dipole pattern. This part of this red part of the sky tells us that there are more cosmic rays arriving from this part of the sky than the opposite part of the sky, which points to a higher concentration of sources on this part of the sky. And we know that if we study the distribution of galaxies in the universe, and we look at where are the, let's say, the galaxies which are closer to our own galaxy, the Milky Way, we get a dipole very similar to this one. We would see that most of the nearby, most nearby galaxies would be on this region, and this region corresponds to would not have so many galaxies close to the Milky Way. So if we would find a way to generate a sky map, a color sky map with the distribution of galaxies weighted on their distance to our own galaxy, we would get something like this. So this is direct evidence that the sources of these particles are galaxies outside the Milky Way, are other galaxies. We don't know still which type of galaxies. So there are many people, even inside the PRLG correlation, that are working in order to try to understand with more or different analysis, try to understand exactly which type of galaxies, if these are galaxies with supermassive black holes and active galactic nuclei in the center, or other kind of galaxies are responsible for this, which ones. But this is a clear indication that the sources of these particles are galaxies outside, not our own galaxies in the universe. Okay, so this is the result of the full statistics. So let me end by congratulating you for your results, for your experimental activity, and for this very interesting discussion. We are 5 minutes beyond schedule, but before we go to Nicholas, so he shows us the observatory, let me just ask from any of the sites, Piacenza, L'Aquila, Catania, or Constantine, if there is a question or other that you want to ask us, a general question, or if you want to ask us before we go to the virtual visit. If that is the case, please raise your hand, and we can answer. I see Constantine. Yes, you can. Yes.
So please, I have a question. What are the corresponding astronomical objects in this region where there are extra density of cosmic rays? Are they significant?
Okay, so we know that in these regions there are many galaxies. There's a higher concentration of nearby galaxies on this part of the sky, and actually the main there are two types of galaxies that are typically searched for when more located searches are performed for trying to find the sources. So smaller searches for smaller regions of the skies, and this corresponds to galaxies with active nuclei, the AGNs, or galaxies which are called starburst galaxies, where these are galaxies which have which are characterized by having a number, stars being formed, a higher, typically higher rate of stars being formed than the average galaxy. So these are typically the two types of possible sources that are being studied the most as possible point sources of particles.
But there's no lacking in models and hypotheses for what they may be the sources, right?
Yeah.
Maybe just to explain what are AGNs, the active so the idea is that there's the black hole in the center of the galaxy in that case. So that's why we say, yeah.
Thank you so much. Thank you so much for answering me. I will let my classmate to tell you another question. Thank you for.
Why there's no another observatory in the north in order to cover all the planets and all the sky?
Actually, there is an observatory in the northern hemisphere, which is in the United States, the telescope array. It is smaller than the observatory, and it allows, in fact, to by combining with the data and the result of the Auger, to have a full sky map with all the regions of the sky covered. In fact, the original idea for the Pierre Observatory was to build it to one observatory, as it is in Argentina, and another one in the northern hemisphere. But for practical reasons, this was not possible. Only the one in Argentina was built. But nowadays, there's also this telescope array in Utah, in the United States, which allows to cover also the northern part of the sky. Thanks for this interesting question as well.
Thank you so much. Thank you for giving us the opportunity and the chance to participate in this amazing masterclass. Thank you so much.
Great. That's great. So now we go to Nicolas. He will take us to Malargüe and will show us the observatory. Nicolas, the stage is yours.
So can I ask a question?
Yes, please.
So did the Pierre Auger, after 15 years of working, succeed in finding the origin of those high energies? If not, can we hope it will succeed in the near future?
That's that's a good question. Maybe I can answer, Nicolas. Well, this is a question that is there for more than 60 years. So since the 1960s, that we know that there are particles with energies bigger than 10 times 20 electron volts. Okay, so this is a long-standing problem. The result that I've showed you before already allows to constrain this origin, so it's a discovery that the source is not our galaxies, actually galaxies are other galaxies. About the future, I would say that probably, okay, the Auger is gathering more data, is now using data analysis techniques which are more and more advanced, and I would say that if I'm optimistic, I would say that in a few years probably this question will have an answer, and we could exactly discover what are the point sources of these particles. So a long way has been done, and let's see if with the new detectors, Auger is entering its so-called phase 2, where besides the tanks we'll have these scintillators like Nicolas has shown, which give additional information that allow for more advanced analysis. And these are tools that will help us in answering this question, and we will do so in the nearby future, in the next years. Thank you very much for your question. So now, thank you, Nicolas, once again for the very interesting visit. Now we go for the last part of the video conference. We're almost finishing, but we'll finish with a quiz. Let me share my screen.